Hi, I'm Gautam Kurmela. We have Akshat Mandloi, co-founder and CTO of Smallest.ai. What is that one unique thing that you're solving in this space?
The architecture that we started with a year ago, our model is almost all of the layers have been changed. I think we are very close to, in terms of hallucinations, we are pretty close to some of the biggest models out there while being very small in size.
Welcome to Seed to Scale, AWS Inside the Engine Room. We have Akshat Mandloi, co-founder and CTO of Smallest.ai. Smallest.ai is making big waves these days. They have the world's fastest TTS engine, which achieves the lowest latency. So tell us, Akshat, what is the secret sauce behind that?
Thanks a lot, Gautam, for having us. I think the secret sauce is just keeping your heads down and building. But I think diving down deeper, I think what we have learned from our autonomous vehicle days, me and Sudarshan were both building autonomous vehicle software stack. And I think the systems are what make a model best, right? So we have focused a lot on building systems around making and supporting the model, right from your data loops to, inference engine, working a lot on GPU levels and working a lot on the data level that actually makes the model great. So as you said, right, you must have heard quotes, right? Model is just 10% of what comes out. So that's actually true. We have applied it in action and it actually works. So that's the gist of it. Probably if you would like to deep dive into any one of the aspects, I can go deep.
You also sort of took a slightly different approach from the traditional auto-regressive models, right, in your architectural approach. Can you just talk about some of those?
Yeah, so we experimented. We right now have both sort of models. One is like a non-auto-regressive and one is an auto-regressive. I think the idea was that we just wanted to, initially we just wanted to understand what works better, because at the time we were starting, there was no clear distinction in the research, right? For example, if you look at text modality, right, it's a clear distinction that auto-regressive works the best, and there's a lot of work there. But when we were starting, there was no clear distinction. So we experimented with both, and right now I think we have both the models. Both of them are one of the world's best. They have their own different properties, and we just use them based on what's the use case, where do we have to deploy them, what do they have to achieve, and on the basis of that, we just use them.
And your Electron SLM claims to have 45 ms time to first token. So how do you manage to get that parameter efficiency and still maintain high conversational quality?
Yeah, so I think as the name suggests, right, smallest. So the hypothesis has always been that large language models can do general tasks and they do it very well. But we were focusing very specific use cases for industries and enterprises, right? So, and we have seen from our previous experiences that even an autonomous vehicle, right, for example, they have a small model that sits on the hardware and does all the jobs of interpreting the environment, etc., all of it. So the same philosophies we have applied. We just extracted the best out of a small model and then worked a bit more on the inference engine to bring down the latencies. And again, like the philosophies, our philosophies across any model are same, that it's the systems around it. So then we worked a lot more on the data side to bring up the efficiencies, to bring up the quality so that they can match the LLMs, while working a bit more on the inference side to bring down the latency. So I think both sides we worked a bit, and now we are able to achieve these latencies.
There are so many TTS models which are out there. What is that one unique thing that you're solving in this space?
The simple take is that model is never the moat. As and when the research progresses, your models would look very different from where you started. And if you are not catching up, you are not adapting to what's happening in the research, your models are going to go outdated. So we apply the same philosophy. I think the architecture that we started with a year ago, our model is almost all of the layers have been changed now, and all of the components look different because the research has progressed. So with that, we also have to build systems so that the moment we change a part of our model, we can quickly do the training again. We can quickly do the changes and adapt to whatever is the best out there. So, that's been the philosophy about how we build our models.
And what are those lessons that you have from calibrating these speech models for different dialects, different languages, and all of that?
So that's a difficult task, right? That's why we have been, I think everyone is struggling with doing it for all of the languages in the world, right? It's very difficult. So, for example, to even though we have trained it for say 16 languages now, if I have to do it for any new language and bring it up to the say same quality that I do for English, Hindi, or Spanish or French, right? If I pick a dialect which is in India or anywhere else in the world, I'll have to spend first of all data gathering. So the more low resource the language is, I think the more time it takes. So that's one. And then you have to find a native speaker who can verify the quality. You have to build systems on top of it so that becomes an automated process so that you get the filtered data out. And then you go about. So training the model just becomes a process then, but the work that you do on data takes a lot of time. And sometimes it's almost next to impossible for at the stage where we are, right? We can't just go around and tackle all of the languages around the world. So yeah, that's a very hard task to do.
How did you go about building these different corpuses for different languages? What was the starting point for you?
So the starting point, I think, for the famous languages or the most spoken languages, not the famous ones. So the most spoken languages like English, Hindi, Spanish, right? There are vendors out there who provide you a golden standard data set. And that's still expensive, right? The charges are huge. So, and the models, on the other hand, if you say, for example, go for an auto-regressive model, you need audio data in around thousands of hours of data for each language. So now to achieve that, we had to work a bit more on amplifying that golden data set to have different speaker variations, different accent variations, different emotion variations. So we worked around a bit, built our own synthetic module that takes in that golden standard data set and amplifies it by 10x, 50x, 100x, and it keeps getting better so that we get all the variations and then we train on top of it. So that's how we have solved it till now.
And especially when you go and talk to enterprise customers in the area of voice agents, I think that's how we are positioned currently in terms of certain offerings that you're building. How are you solving the problem of hallucinations and all of that? Especially, it's more straightforward in the text domain, but from a speech standpoint, how are you handling those things any differently?
So I think the way our voice agents work is like still a cascaded system right now. We are working on the voice-to-voice space, but as you said, right, even with text now, LLMs also, people are tackling hallucination problems. So solving it on a speech-to-speech domain in a large language or audio language model manner, I still feel that that's a bit of research that has to happen there. But in a cascaded systems, right, since you have a small language model in between that is powering your intelligence, it has become a bit easier to control the hallucinations. That said, I think there's still some way to go. According to our benchmarks, I think we are very close to, in terms of hallucinations, we are pretty close to some of the biggest models out there while being very small in size. So that's one of the, and that is an outcome of the way we have constructed our mechanisms around how do we deal with a conversation, right? So we have broken it down into pieces. In the background, the user doesn't know what's happening, but in the background, there are processes running that make sure that the conversation doesn't go anywhere. It closely follows what the user wanted or you want to convey to the end user. So there are a lot of guardrails. There are parallel models that run, which actually help us keep the model, which is answering in a perfect shape, or in like it follows a certain guardrails basically.
So changing gears to a slightly different topic, which is hiring, one of the most important things. What was your mental model from building that initial team that you had? What has worked for you?
Yeah, so I think when me and Sudarshan started, we are both hardcore data scientists, also product guys. So we have built teams, we have hired teams. We have been part of early stage startups. So we have seen it all. And I think since we are building a company where we wanted to own the whole stack, and that is where we started. We started with building a model, and then we went to the application layer. So one thing we realized is that from our previous experiences also that finding folks in the area is very hard. So you have to have a very great top of the funnel. So until and unless you have like you can present yourself as someone who is actually tackling very challenging problems, you won't be able to get a very huge top of the funnel. That's one problem we solved by just showcasing what we are doing, coming out with what are the problems we are solving, both on social media, LinkedIn, Twitter, etc. worked very great for us. Just showcasing what are the outcomes that we are achieving, right? So that helped create a top of the funnel. And then once you have a top of the funnel, the other problem comes is that whenever you post, for example, one of the posts that we shared about one of the hirings that we wanted to do for a data science role, I guess, or a full stack role, it went viral. Now, one of our mailboxes keeps getting a mail every few minutes since we have posted, and that's well like 3, 4, 5, or maybe more weeks now. So that becomes another challenge. So how we have solved it is that since like I was in Bosch, I was also hiring for them, for the team. So I think intuition has developed on the basis of what the person has done. So the top of the filtering becomes a bit easier. We are especially looking, and when you are clear for what sort of folks you are looking for, it becomes even clearer. So I think that intuition plus the clarity of what exactly you want from the role helps us filter down these things very quickly. And that's why we don't look at JDs. We just want a 100-word description of how do you work, what you have done, what's the best thing you have done, and we just judge on the basis of that. And then the rest of the process is fairly straightforward. We have a technical review, we have a fitment round, and that's it, basically.
And looking ahead, what is most exciting for you? What kind of, is it product, is it technology, or the opportunities that you have in front of Smallest?
So I think the overall philosophy about voice that I have right now is right. As a human, voice is one of the very first mediums that we interact with world, right? Text comes later on. So I feel that the same is gonna happen in the web space. We will have interfaces where people will interact more through voice, be it websites, callings we are anyways doing through phones, etc. Right? And these these things would come to you, rather they will be very proactive, so they will come to you. So the interfaces would change in that manner. And we are just scratching the surface of automating even the boring tasks with speech. So, enterprises have just started thinking about how do we implement a voice AI automation workflow, or how do we augment the current systems that we have around speech. So we have a long way to go. Obviously, a lot of research is going to happen there. And I think I feel kind of lucky to be in a spot where we are at the forefront of doing all of that applied research and then helping out enterprises shape their voice AI journey. So very excited for the times ahead. I can see like super interesting use cases that are going to come up, which people have not even explored yet. There might be more markets that might open just because voice will become a primary interface between humans and AI.
Yeah, word without clicks, right? I think
exactly.
That's what everyone's talking about.
So super excited about the times ahead. The journey till now has been super exciting, and I think it looks even more exciting going forward.
Thanks, Akshat. Thanks for joining us, and thanks for sharing your learning.
Thanks, Gautam. It was very interesting to talk to you about voice AI and stuff. So really thanks for having me here.
Awesome.
Thank you.
Thank you.